All right, so here is 6.2 part 2. I wanted to review your trig identities real quick. So if you remember, I was a big meanie and I made you memorize your Pythagorean identities. So we are going to use them again in some way, shape, or form. So those are there for you. I wanted to talk about your reciprocal identities. Um, you know that like sine is the reciprocal for cosecant and things like that. But the main one I wanted to talk about won't be the only one, but I want to make sure that you guys understand. You've got cosine, which is sine over, or not cosine, tangent, which is sine over cosine, which is also x over y. And then cotangent is the reciprocal function of that. Okay, so you have sine over or cosine over sine, and then it's x over y. But your sine does have your cosecant, that is the reciprocal identity. You've got cosine that goes with secant. So those are big too, but make sure you understand the tangent and cotangent. And then real quick with your Pythagorean identities, to get sine squared, you would subtract cosine squared over. To get cosine squared, you would just subtract sine squared over. And then to get tangent squared, you would just subtract 1 over, so it's secant squared theta minus 1. And then cotangent squared, same thing, you would subtract 1 over, and you would get cosecant squared theta minus 1. So these are a few things to just kind of have and, you know, right up in front so we can use them, because part of eliminating parameters is eliminating parameters of trig functions. All right, and that's what we're going to talk about in example 5. So make sure that you've got this information ready and available to you. So for example 5, we're going to eliminate the parameter for the following. So we have x equals sine t and y equals 2 minus cosine squared of t. So one thing we want to make sure that we understand is in 6.1, we said that, um, not even in 6.1, but just in general, that x is related to cosine theta and y is related to sine theta. It doesn't change when you're talking about parameters. Um, so with parameters, instead of having cosine theta, you have cosine of that parameter t, and y, same thing. It's sine of that parameter t. So it's just the angle or the function that you're looking at. So instead of having theta, we just have it as a function of t. So for this problem, again, we're trying to substitute and simplify as easy as possible. Okay, we want to make it as easy as possible. Okay, so think, what would be the easiest thing? All right, so what would be the easiest thing that we can do? So I want to take a look at what we have available here. So we're going to use both of our equations that we have in some way, shape, or form. So I want to take a look at this one first, okay? It's not going to be super crazy easy to do, and none of this really is. But I have something in here that I can use and I can substitute because my x is equal to sine t, and then my y has a cosine squared in it. I want to get my trig functions to be the same. Okay, to me, that makes sense. I want to get my trig functions to be identical because that makes substituting a little easier. So we had just talked about how to get cosine squared theta. Okay, and cosine squared theta gives you 1 minus sine squared theta. I'm going to take that information, even though it's a theta instead of t, I'm going to substitute so I have sine functions in my problem. So I have 1 minus sine squared of t, all right? I'm going to do a little bit of algebra because I've got that minus sign in front. So I've got y equal to 2 minus 1 plus sine squared of t. Okay, do a little bit more algebra. So now this is just 1 plus sine squared of t. So now I'm not done because my parameter is not eliminated. I still have the t in there. All right, I still have the t in there. I don't want it in there. I want it to go away. So I have to start thinking about my other equation. So you're probably wondering, why did I choose this equation first? Well, if you look at x equals sine t, there's not much we can do here. Okay, there's not much we can do with that. But looking at it now, if I'm trying to eliminate a sine squared, if I take my x squared, if I take my x and I square it, I'm sorry, if I take my x and I square it, that means I also have to square the right side, and I have a sine squared, and I have a sine squared of t. So if I square both sides, I can now eliminate that parameter, and now I have a function that has both x and y coordinates in it, and my t, my parameter equation is gone. Okay, so this is my equation that I want. All right, so I'm going to have you do example 6 on your own and try it, and then I'm going to walk you through it. So example 6, we have x equals sine squared and y equals sine to the fourth. So I need to look at where I want to substitute. Okay, what do I want to substitute for? So if I'm looking at what I don't have much, right? I don't have much, but I do have this sine squared, and this is really sine being squared twice because it's to the fourth. So what if I took this x and I substitute it in here for that sine to the fourth? Now, that's a strategy I'm thinking of. In order to make that happen, I need to have a sine to the fourth. I don't have one yet. So before I can substitute anything, I should square both sides. So if I have x squared now, the square of sine squared is sine to the fourth because of our exponent rules. Now I have exactly what I need, so I can take that x squared and substitute it in for sine to the fourth t, and now my parameter is gone. I have no t, I have no trig, I just have a parabola. That's it. That's all I have. Okay. I'm going to have you do example 7, and that's a G, not a Z. Super fun. Okay. So, and then I'll walk you through it. So for example 7, we have x equals cosine squared of t and y equals sine squared of t. So if you recall our Pythagorean identities from the beginning of our notes, okay, we need that section. I told you to have them handy and ready. We do have information for cosine squared and for sine squared. So it does, in my opinion, it doesn't matter which one you eliminate because they're both just as simple. So I'm going to go ahead and take my sine squared and substitute it in for 1 minus cosine squared of t. Okay, I want my trig functions to be the same so I can substitute easier. Okay, so you want the trig functions to be the same. Okay, so now that they're the same, I have a cosine squared of my parameter that is in both equations. So now I'm going to take the x and I'm going to plug it in. So now I have a linear equation with no parameter. All right. So that is my final answer because now the parameter is gone. I'm going to have you do example 8 in Edpuzzle, and then I'll walk you through that one as well. So for example 8, we've got x equals 2 sine of t and y equals 2 cosine of t. Again, there's not much that you can do right off the bat. But if you recall, we've got x is cosine and y is sine. Okay, and that's going to be used to our advantage here. Again, you need to have all those trig functions ready and available of things that we've done so far and things that we learned in 6.1. So um, for these guys, I'm just going to do a little finagling because, yeah, you like that word, finagle? Because I'm going to use my Pythagorean identities along with my x and y's, what they equal, to solve this. So for this one, I'm going to go ahead and I'm going to square both equations. Okay, so now I have x squared equals 4 sine squared t, and I have y squared equals 4 cosine squared of t. So this kind of piggybacks off of 6.1, where we would square things to get r, and then we would solve for x and y. So we need to make sure that those skills from 6.1 we're rolling over into here. So now with our trig identities that we have a sine squared and we have a cosine squared. I want to get both of my trig functions to be the same. All right, so I'm going to go ahead and try to change my sine squared to cosine squared. And to do that, I just substitute in my Pythagorean identities. Okay, so now I have cosine squared. Okay, I have a cosine squared here and a cosine squared here. Okay, but neither of the cosine squares are by themselves. I'm going to go ahead and backtrack real quick. I'm going to put and do this. None of the cosine squares are by themselves. So you need to follow the guidelines that we talked about with parameter and get the parameter by itself. So if cosine squared t is our parameter, I'm going to divide by 4. So now I have y squared over 4 equals cosine squared of t. Okay, I still have my cosine squareds, but this cosine squared right here in blue is now by itself. I'm going to take what it equals and I'm going to substitute it in to the other equation. So your whole goal is to eliminate the parameter. Sometimes you're going to have to square. You're going to have to get the trig functions to be the same. You're going to have to do a little bit of algebra. So in doing all that, we've got some substitution and some algebra to do. So x squared equals 4 minus 4 times this fraction. This 4 cancels because one's in the denominator and one would be in the numerator. So we've got x squared equals 4 minus y squared. I'm going to go ahead and move my y squared over just so they're on the same side like we did in 6.1. Because then it looks like something we did in 6.1 where x squared plus y squared equals r squared. Okay, but this is our new function, our new equation without the parameter. Okay, but this is what we learned in 6.1, and this is the similar equation that we found. All right. If you have any questions, come and see me during office hours. That's what they're for. We'll do some practice and move on from 6.1 and 6.2. Have a good day. Come ask questions.